voice in the back. So in German we call it Bauchredner. I don't know what's the English expression of that. But I would like to hand it over to you. So please, it's your stage.
I'm the president of Scrum and Hardware at Scrum Incorporated in the United States. I spend 3 weeks out of 4 on an airplane somewhere in the world training, coaching, and consulting in Scrum in hardware manufacturing. I also work in research and development, petrochemicals, pharmaceuticals, medical, but a lot of it is hard iron manufacturing. I'd like to share what I'm learning about this so that more of the people attending here can experiment and deploy the rapid innovation cycles of Scrum in their environment, no matter what you make. You may have seen me before. I'm lucky enough to have been written about in Forbes 5 times. I've had the luxury of lecturing at Cambridge in Massachusetts at MIT and Cambridge at the University of Oxford in England. I've had a chance to do a TEDx talk that some of you may have seen. I'm the creator of the extreme manufacturing method, applying Scrum to hardware development. And Deloitte Consulting Group sent a team of consultants to one of my factories for the automotive manufacturing business that I own. They spent 3 sprints, which for us is 3 weeks, in one of our factories. And they wrote an article about it in CNN Money. And I was very worried. I didn't know what they would write. The title of their article was How Every Company Should Train Their Staff. I was very lucky. But I do think there is some business impact to deploying Scrum across every industry. And I'd like to share with you the best I've learned so far about that. Lockheed Martin called Scrum Incorporated my full-time job as a Scrum trainer, consultant, and coach for hardware teams. And Lockheed Martin called us at Scrum Inc. and said, we have a problem. Our F-35 jet fighter, our Joint Strike Fighter, is $143 billion over budget. They said it's delayed until 2022 before we ever deliver a plane to any of the world's militaries. They said the cost per plane in 1 year went from $273 million to $337 million. They said, here's the real problem. Saab has a competitor that's also a stealth multi-role Joint Strike Fighter. It has the same role. It started the same quarter of the same year as our project, so people keep comparing us. They release a new jet iteration every 6 months with more features than the previous iteration. They said, Saab has released 4 flying iterations and we have yet to release our first one. They said they're using something called Scrum. They said if we don't figure this out, we're going to lose all our contracts. The United States Congress doesn't even want our plane anymore. They said it's so bad, our plane is now a meme. Not only is it $1.5 trillion, but the World Health Organization says that's enough money to feed every hungry person on the planet for 50 years. They said, we don't want projects like that anymore. I don't get to tell you what we got to do in Lockheed Martin, but they put this video clip on primetime news every night for a week straight.
Some Silicon Valley engineers who work on top-secret military space systems got to test their problem-solving skills today. Lockheed Martin challenged them to a down-to-earth project, building a car in just one day. ABC 7 News business and technology reporter David Louie is live in Sunnyvale. David, did they make their deadline?
They did make their deadline precisely 9 hours later. You know, engineers are always fond of saying they're up for a good challenge, and the executives here at Lockheed Martin decided it might be good to help them push their thinking through, you know, to think outside the box. And they found the perfect vehicle to do it: this car.
1, 2, 3.
Lifting off a tarp isn't quite as dramatic as a spacecraft liftoff, which is a routine part of their work. But these engineers couldn't be happier about how this day-long project ended.
My name is Amanda Fu, and I'm a rocket design manager here at Lockheed Martin.
And what do you know about building a car?
0.
That's how these 200 engineers started out their day. Their goal, to build a car rated to go 100 miles per gallon. It was a team-building exercise by Lockheed Martin to inspire its engineers to rev up their creative juices and to get them to be better problem solvers.
It means that failure is not an option. They have to very quickly pick up the task, find their way through it, make sure they're doing it correctly the first time, because there's really no time to cycle back through it. And even in the normal products we build that take much longer, that's still a truism that they have to live with.
This wasn't designed to be a simple assembly process. Curves were thrown in to create challenges.
We have about 4 inches of error in the drive assembly, so we have to adjust where the tires are, adjust where the wheel assemblies are, and adjust ultimately where the engine is.
Easy to fix?
Easy-ish. Easier than the body.
The car itself is a prototype created by Wikispeed, an organization working toward a highly efficient commuter car. A buyer has paid $25,000 to take this team-assembled vehicle home. And by working all day as a team, Lockheed Martin employees hope to walk away with new skills to use in their daily work.
My group does a lot of supply chain strategy, so if we can see how things are built, see what the parts do that our group is buying, it really helps us understand how we contribute to the organization.
In Sunnyvale, David Louie, ABC 7 News.
Did any of the Scrum coaches in the room detect the problem in that video clip?
Get it right the first time.
So they panned over leadership. That guy was one of the execs. They said, there's someone in a sport coat. Let's make sure we film their reason for why this activity is happening. And he got it all wrong. He said, failure is not an option. They have to get it right the first time. The entire point of working in sprints to inspect and adapt is to learn and improve and learn and improve and learn and improve. That was completely lost on everybody above mid-level management. That was eventually fixed when we had leadership go through and build cars. Here's what I currently see when companies deploy Scrum to build satellites, battleships, missiles, petrochemical plants, beer. It's usually a lot like this. First, they redeploy the company into Scrum teams. Typically, that means taking the number of people in the organization that's going to try Scrum, dividing it by 5, and that's the number of teams they have. They divide that by 5 again, and that's the minimum number of full-time Scrum coaches they have internally. Yahoo conducted a study on teams with a coach versus teams without a coach and their improvement in velocity. Teams without a coach had a 35% improvement in velocity. Not bad. teams with a full-time coach with no other work other than to be a Scrum coach, in addition to the team Scrum Master, improved 200 to 400%. And they calculated that each Scrum coach's return on investment was more than $1 million per year. So you could pay those coaches a lot of money and still come out ahead. Secondly, just like any software delivery, if we don't deliver high quality every sprint, it's not usable. In hardware, that matters too, especially in life-critical systems like jet fighters or infant defibrillators. For that, we use the XP, the Extreme Programming Practices. Pairing, swarming, test-driven development are the top three that they start with. Eventually, we get to customer at the center and all of the XP practices. This then does inform the way they set up the manufacturing line. I'll show some pictures of that later on, but it does change the types of machinery they use, the types of materials they use, and how they arrange them. Just like in software, we used to have the idea of a cubicle farm with people not talking to each other and walls in between. Well, that's not very different than most manufacturing assembly lines, where they have just their lean cell and no communication with the next piece of flow. So that's had to be rebooted as well. Then, in software, we already know it's going to be really slow if we don't do object-oriented architecture. This came from hardware in the 1950s, but they've forgotten it. When we boot up a Scrum team, if we're talking to a software Scrum team, we usually don't even have to mention object-oriented architecture anymore. In hardware, we have to start the class with object-oriented architecture and how to split their hardware solution into loosely coupled modules, where each module is a viable experiment to provide customer visible value, just like software. Let's see what this actually looks like. On the left is a milling machine at Toyota Motor Company. It costs more than $100 million. It produces blocks of metal, of steel, that are the shape of a car door. Then they take sheets of metal and press it to make car doors. That piece of metal underneath is called the stamped steel die. That machine can make one a day. The machine on the left, is $2,000. It also makes dies to create car doors. It also can create one car door design every day. The cost to engage in mass manufacturing is completely changed. The idea of a high cost of entry, even into traditional mass manufacturing markets, is completely different now than it was even 10 years ago. So Toyota is as concerned about a fast-moving startup as any software company is. They realized that the competitive advantage of scale is gone. And now it is about how quickly can they deploy the next generation of their product. Because right now, they're on 3 to 5 year deployment cycles. They're using Scrum, it's just 3 to 5 year long sprints. In Scrum, lean is the essential foundation. Use less stuff without frustrating your customer. It's one of the 12 Agile principles. Maximizing the amount of work not done is essential. All of Agile development in hardware or software, including Scrum, is based on an effective use of lean. But lean by itself isn't enough. Lean is systemically eliminating waste. Variance is considered waste. Lean Six Sigma means having 6 decimal places before you experience variance. But innovation is variance. If we only deploy Lean, we tend to stamp out all innovation and have longer and longer and longer new product development life cycles. If we add Agile with Lean, we have fast new product development cycles on regular cadences and using less waste. I would say that that's Scrum, the art of doing twice the work in half the time. This involves focus from leadership, and if it's going to work in hardware or software, leadership needs to take on as their #1 responsibility identifying the gap between the way the company behaves now and what perfect Scrum would be. In every sprint, they remove at least one impediment and demo that to the company so everyone sees the progress. With just that, with just leadership being a Scrum team to remove impediments in the continuous deployment of the company, we have the most profitable companies in the world right now. According to Forbes' top 10 IPOs of all time, market capital generated on the stock market, all of the top 10 IPOs are companies using Scrum, every single one. This relies on a few essential ideas. The unit of manufacturing is a group of people who work together to produce a component. If they're a Scrum team, they then improve through retrospective every sprint cycle. They have a regular cadence of continuous improvement. If we split our hardware solution, not by layers of functionality, but in vertical slices of customer visible value, and we deliver a little bit of every slice, every sprint, we have rapid releases. That is object-oriented architecture. So not delivering a car with 2 wheels, and then the next 2 wheels the next sprint, but delivering a complete car, and then a car with better, a little bit of every module the next sprint. This is related to having short feedback loops, where the time it takes to go from an idea to seeing the customer use that idea is as short as practical. For companies that are on 3 to 5 year sprints, there's a lot of opportunity. Shortening the supply chain enables short sprints. If we have faster shipping or more co-located manufacturing, we're able to see shorter and shorter and shorter sprint cycles until some of these companies are on 1-week hardware sprints, from design to deployment of the entire product. If they're going to be developing new product designs on a faster cycle, potentially as fast as 1 week, that doesn't do them any good if they can't manufacture it in volume. If it takes shutting down the factory for 3 months to deploy a new design, then the shortest sprint you could be on is 3 months for a new product design. To shorten the time it takes to deploy a new idea to mass manufacturing, we employ the abstract factory pattern. For those of you familiar with the patterns movement in software development, that may be very clear. To most people owning factories around the world, that's a very new idea. I'd like to show you what it looks like in companies that are trying it now. First, here are actual Scrum teams working as lean cells. This team is in New Zealand. They make radio base stations for the military and commercial purposes. They take their takt time, the amount of time it takes to produce a lean product and flow it out of their cell, and they augment that with the sprint cadence. The sprint cadence provides their retrospective time, where they have time off the line to inspect and adapt to improve the line and the product. The retrospective becomes the engine for their lean process improvement, their Kaizen. Their pre-shift daily stand-up becomes a Scrum ceremony by adding a product owner and a Scrum Master. With those two roles, they now have focus on exactly the new thing they want to build today, instead of merely perfecting what they did yesterday. With the Scrum Master owning continual process improvement and cross-team coordination through Scrum of Scrums, they're able to affect change across the manufacturing room every day, instead of shutting down the plant for 3 months, which was the legacy truth. Here's Volvo's scalable product architecture. Volvo says they can use this from everything from a 1-seat car to an 18-passenger vehicle. From single-seater sports vehicles to multiple-seater utility vehicles, they're able to use a single pattern language. What they've done is treat their hardware like it's software. They've divided the platform into loosely coupled modules with known stable interfaces. Engineers can independently redesign and build and deploy each section of this vehicle, and they're reconnectable at the known stable interface points. Here is an example of known stable interfaces. These are suspensions attached to one of the cars that my company, Team Wikispeed, produces, and we sell these cars. Some of the class attended a certified Scrum Master class here at Scrum-Day on Monday and Tuesday, and they built one of these cars in 2 days as their capstone project to graduate as certified Scrum Masters for hardware. These suspensions all attach with the same 8 bolts. Any suspension that uses these same 8 bolts can be switched at any time, from articulated spider legs to tank treads to floats and a propeller. And we're able to change these to cars we've already sold at any time. This lets customers have a degree of flexibility that's completely new in automotive manufacturing, and it lets us deploy hot fixes. This also enables a pattern language. In software, when was the last time any of us had to write a bubble sort? Now we simply use one of the sort patterns that's going to fit well for our data store type. We can do this now in hardware. Think about how much faster that's enabled software development. It's blowing the minds of factories. For supply chains, we've never had more real an example of the benefit of short supply chains than the tsunami in the Japan area just in the last few years. The more inventory that's out on boats, in trains, and in vehicles is 1, inventory that's not being able to be used, and 2, inventory that's at risk. From an Agile perspective, it's even worse, because that's inventory that is not enabling our feedback loop. And if we learn how to make a better product that says, let's use a different part, we have to wait till all our supply chain completes a cycle before changing supply and sending it back out to the chain. So that is the limit of our sprint length. Our sprint length can't be any shorter than our longest supply chain link. This enables some companies to be as radical as put every piece of machinery in the factory on wheels. They say, by being able to mix and match the way the manufacturing line flows every minute, they can continually optimize based on the Scrum team's retrospectives. This enables the abstract factory pattern in hardware. These companies will do what they're now calling massively parallel concurrent manufacturing. The factory floor looks more like a hyper-threaded processor than anything we've seen in hardware before. The entire hardware floor is divided in a grid pattern with tape or paint. In Lean, they call it a shadow box. In that area is one Scrum team. They have their own machinery, and it's all on wheels, and they determine how it's arranged. They have a known contract, an input-output, with all the other Scrum teams, and material flows across a known stable interface. They're mimicking objects in software. As a result, if you want to make a change to an object in the factory, it's as simple as the one Scrum team executing a retrospective. Instead of a top-down command and control restructuring of the factory, which used to require building a new factory. That was a $60 billion or more investment in any change. So no wonder good ideas were queued up and queued up and queued up and not deployed for 3 to 5 years, if at all. Raytheon then called and said, we have a problem with the Patriot missile system and other systems that I'm not allowed to name. We started working on Scrum there. Then John Deere Tractor sent 3 of their managers over to one of my factories. They said, we need to learn about Scrum and hardware. We got drunk together, and then we built a car. They then flew me to their headquarters in Moline, Illinois. We trained their entire team to develop new tractors, combines, seeders, and harvesters in hardware. That training took 1 week. The first 2 days was a certified Scrum Master class. Wednesday, they took their requirements and created a single prioritized backlog and estimated it. They also created their definition of done, their definition of ready, and their team working agreement. Thursday, they started scrumming, and I got to stay as a coach. Same for Friday. I flew back for their first demo 2 weeks later. In 2 months, they had doubled output. They measure that in John Deere by the number of business plans transitioned to be manufactured. Without changing any employees, no one hired or fired, in 5 months, they'd gone over 6 times their original speed per employee. In 16 months, they had reached 7.2 times their previous velocity. We then repeated that together in India, in Brazil, another office in the United States, and then Kaiserslautern, Germany. But the Germans refused to estimate in points. In 2 months, the Germans had still estimated all of their works only in hours, and they were wondering why they hadn't doubled velocity. They said, we started working up to 60 hours a week, but we can't hit double like all the other centers. In 5 months, when all the other centers had gone over 5 times as fast, they finally folded and said, okay, let's try this points thing. They re-estimated their completed work using the same reference stories all the way back in points and saw that they also had accelerated to over 5 times their legacy pace. But they hadn't been able to see it in hours. Then they started celebrating. I then got to be one of the 2 Scrum coaches for Microsoft's Xbox One and a Scrum coach for HP Labs. Paul Tacken then invited me to TomTom in the Netherlands. He showed me TomTom OS running on his watch. That watch had been in the backlog at TomTom. Let's deploy our navigation system to a watch for more than 2 years. But they said, we don't have enough resources to do it. That's broken thinking. We don't have enough resources. By that they meant people, but they weren't respectful enough to call them people. They just called them resources. They said we don't have enough people to take on these good ideas. Instead of thinking, how do we get stuff out of the way that's frustrating or slowing down the people we have so they can get more done, which would be an Agile method. Paul, as one of the Scrum coaches there, had been so successful that they were hosting a party to celebrate the Scrum Masters and the product owners. They rented a floating dance hall where Ian Van Dahl, the DJ, had played to crown the Dutch King and Queen recently. And they had a blowout party for their product owners and Scrum Masters. They did this because they were getting all the good innovation ideas done that the company didn't think they could do and getting all their current work done. Stuff like having TomTom deployed on a watch and having TomTom deployed on a Volvo. TomTom was not available on a Volvo before. I'd like to invite Paul Tacken to talk for just about 5 minutes on all the Scrum hardware work he's doing here in Europe. Folks, if you'd let me share the stage, I'd ask you to help me invite Paul Tacken.
Thank you. So I'm almost out of words now, like you. Yes, I'm Paul Tacken. I'm an Agile coach. I'm doing most of the time corporate transitions of Agile, not that sexy. But I'm using a lot of stuff experience done by HC manufacturing or hardware Scrum. This is my latest project. Let's see if it works.
Turned out that our lap time was about a minute quicker than any hydrogen electric car has done here in the past. So I think all the guys at the TU in Delft has a lot of reasons to be extremely proud.
The last picture you see was our next goal, driving the 24 hours of Le Mans in 2 years. That's our next goal. We're starting this summer. Accomplishing the mission was awesome, but the journey was more epic. It's all about the youth as the future. It's about really the root cause of getting things smoothly into Agile. What did we do? Actually, Joe and I visited the University of Delft. There are a couple of guys trying to build a hydrogen car, but they were stuck in Gantt charts and all kind of stuff. They said, well, Scrum is a good thing, let's try it. So they get started, but not in a proper way. So I adopted a team in my evening hours, and then with beer and lots of fun and pizza, I get them started as an Agile coach, getting the things right by the lessons learned by Joe in Seattle. So what did I do? Just what Joe explained, introduced the right practices and the right principles, like a proper garage, just get it neat. And also getting a proper story mapping been done, because for example, they were building at a car, driving 200 kilometers an hour at once, but it doesn't work. You should just do it by steps. So first get the car only roll out of the garage, push it out of the garage, braking, just the braking system works. Then for example, let the EcuPacks do their job and drive for 20 miles an hour, and so on and so on. And in the end, we could accomplish driving this record on the Nordschleife by only 60% of the power, because we use Scrum, and by Scrum it's like, okay, this is enough to beat the record of Toyota, so that was enough, record and mission accomplished. But actually there are two much more important lessons according to me. That's also the Agile mindset and learning all behavior, and inspirational leadership. Let me tell you something more about that. Unlearning all behavior. Like Dr. Russell Eckhoff already said, parts from the best automobiles put together cannot build the best car in the world, because what the guys were doing actually, they were, for example, they were studying electroengineering, aerodynamics, and they were just focusing on their part, but not really on the car by itself. So not helping each other. It sounds simple, but it's more in the mind of people to help each other. For example, there was a guy named Remco. He was the only electroengineer in the team, and he was like 20 hours a day busy and almost had a burnout. And he said, well, I'm just doing everything by myself. Well, can you do anything? Can you just move something to your colleague? No, I have to do everything by myself. For example, what we asked him to do, so just grinding those bolts, can your colleague do that? Yes, actually they can. So it sounds very simple and straightforward. It's not. It's in the mind of those students that they should fix everything by themselves. And the last thing is actually, said many times before those 2 days, various learning is also value. If you capture the data, but then for example, the accumulators of a hydrogen car are very complex. You have to do it over and over again to get things running and measure it right. And it's done like 2,000 times. But it didn't capture the data, so they failed over and over again, and they get demotivated. So what happened then was that, nice is the thing of Agile, but we fail and we learn, but we don't capture it. So we installed systems to capture those learnings and also distribute it throughout the university, that they also could learn from the lessons done there. And also, inspirational leadership is very important. Those guys are often very pushing the limits, and they were really almost desperate sometimes, working long days. And inspirational leadership is very important there. There was a Berkeley report on Joe, where they stated that actually Joe visiting those conferences over here right now was really slowing down the productivity of Wikispeed itself, because his inspirational leadership was needed there. So, Joe, what are you doing over here? And that was actually very important, that inspirational leadership. Jan Lammers, he's a very famous Dutch Formula 1 driver from history. He came by every week or 2 weeks and explained to those students that keep up the morale and told stories about his own history and experience. And it was very, very, very useful. And there's more. The success is that big within the University of Delft. All kinds of projects are approaching me and Xebia, the company where I work for, to help them also implement Scrum in their hardware projects. For example, we're building right now a solar speedboat and a solar racer. The solar racer actually won already 5 times the World Championship of Solar Racing in Australia, but they want to come even better as well. Please, let us try Scrum to be even more better. We like this Agile mindset a lot, so please, Paul, help us there. And actually, the most important thing is down to the left is Agile Scrum. It's really the root cause of really get the right mindset in place. For example, unlearning in big transitions with, for example, now I'm doing a transition with ING, 3,000 employees of ING. Overnight, were transformed into an Agile organization like Spotify. So that's been done. You train those people, and then it takes like 3 months, and then the board of directors of ING said, well, then you're Agile. No, the learning of all behavior takes really years and years to follow. So that's one of the most important things. So we can get more value out of people to teach them, to these students and also little children in school, how to apply Scrum. And Agile Scrum in Netherlands is really getting big. Every week there are more schools applying Scrum in their classes. And students are really like, the grades go up with 20% or something, because they not like, I said before, not to think not in time, but they think in value. They say, okay, how do I get, with the use of Agile tools, achieve my learning goals, instead of just only focusing on what I have to learn. But it's very important that we try to solve the root cause of the Agile mindset, which is learning in school. It's very, very important. It will also save lots of money, but that's not an important thing, of course. It saves a lot of money and time later on to fix those Agile mindsets within corporate organizations, and also, of course, small organizations. So that's what I was trying to tell. It really, the future looks very, very bright, what's concerning me, and I'm really excited to tell this story to all of you. It's really, really a very, very good, nice and good time to be an Agile coach. And lots of things happening. So thank you for your time, and let's make this world a better place.
So if you can, please volunteer some of your time with a school, so these people don't have to unlearn their schooling. I've listed here the top reasons why companies say they can't use Scrum and hardware, or as I like to call it, top excuses.